Hello, everybody. Today, let's simplify this radical using the product property. All right, so the product property normally says that if you have the square root of A times the square root of B, we can rewrite that as square root of AB. That is, if you have two radicals and you want to multiply them, then you can just multiply the two radicands A and B and put them under one big radical. Well, here, we don't have two radicals, but instead we have one big radical. And so the thing to do is to do this thing in reverse. So we'll start off with square root of AB and then rewrite this as square root of A times square root of B and see what happens. Okay, now so we got to think of two numbers that multiply to 90. There's many combinations of that. There's 10 times 9. There's 45 times 2 and a lot of other ones. All right. But maybe you wonder, which combination should we use? Well, what we can do is just go through trial and error and then figure out maybe which one is the best one. But let's suppose we've done all that. Let's just choose 10 times 9. So let's rewrite 90 as 10 times 9. And now we can rewrite this as square root of A times square root of B. That is, whenever you have two factors inside the radical, we can just split this apart into two different radicals and split them apart where the time sign is. And so this becomes square root of 10 times the square root of 9. Now, what can we do with that? Well, it just so happens that square root of 9, it just so happens that 9 is a perfect square. And so we can rewrite this square root of 9 as 3. Square root of 10 is not, but that's okay. We'll just bring it down to square root of 10. And so that 3 doesn't mistakenly get put right here and make it look like 103 or even something like this. We usually put the number in the front in order to avoid it from being inside the radical. So we have square root of 10 there, and then square root of 9 is 3, so we'll put it here. And so we got 3 times square root of 10. Here's another way to do it. Here's way number 1. So let's do way number 2. Let's make a factor tree of 90. So to do that, think of two numbers that multiply to 90. And so we can say, for example, 45 and 2. And now we'll think of two numbers that multiply now to 45. So for 45, we have 9 times 5. Now, think of two numbers that multiply to 2. Well, we could say 2 times 1, but 2 times 1 is not going to help us at all, and that's because 2 is prime. So whenever you have a prime number, just bring it down like that. Now we have 9, 5, and 2 in the same tier. So 9, what two numbers multiply to 9? Well, that would be 3 and 3. 5 is prime, so bring it down. 2 is prime, bring it down. Now all four numbers that we have there are prime. So we can think of 90 as 2 times 3 times 3 times 5. Now we want to find square root of 90. To do that, we're going to put like numbers, we're going to meld two like numbers into each other. So, for example, 3, there's a 2 3s, so we'll meld those into 1 3. Now, if we had two 2s or even two 5s, we can meld them together as either 1 2 or 1. We can meld them together as 1 2 and 1 5 respectively. But we don't have that. So we put them under a radical. So we have square root of 2. And then 5, same thing. There's just 1 5. So just put that under the radical. So square root of 5. And now we can apply the property. We can apply the product property in this case. So we have 3. And then square root of 2 times square root of 5. So we can do 2 times 5, which is 10, and put them under the radical. And that's another way to get the correct answer, 3 square root of 10. Now let's check this to make sure we have the right answer. One way is to use the Desmos calculator. Let's put in square root of 90. And it's about 9.486832981. Now, let's put in the answer, which was 3 square root of 10. And we get the same decimal, 9.486832981. So since we got the same decimal for each of these, then 3 square root of 10 is definitely the right answer. If you get a different decimal for each of those, then we did something wrong. We have to go back and try to fix what we did wrong. All right. Okay, so that's how to simplify a radical using the product property.